This is the solution guide to your half-life problem worksheet. This is a formula used to calculate number of half-lives of radioisotopes. So you start with the elapsed amount of time that has passed. When you divide that by the actual half-life of that isotope, it'll tell you the number of half-lives that have occurred. Okay, in this problem, you know the number of half-lives and you know the actual half-life of this radioisotope. You don't know the elapsed time. That's what we're trying to solve. And so we're going to set up this formula. We don't know the elapsed time. We're going to call that x. The actual half-life of this radioisotope, 5,730 years. And it says that 4 half-lives have passed. So there's 4 half-lives. How am I going to solve this for x? You're going to cross multiply. So you're going to take the 5,730 times the 4 half-lives, and your calculator is going to spit out 22,920 years. If I want to do this for sig figs, you're going to notice the 4 I'm not going to count for significant figures because hopefully there isn't an error in counting to 4. But the 5,730 has 3 sig figs. I would probably report this as 22,900 years. Alright, in this problem we don't really need to use that formula because you'll notice that we have 32 million radioactive atoms. We want to know how many remain after 5 half-lives. So essentially what we have to do is take this number, the 32 million, and we need to divide it in half 5 times. So we're going to cut it in half. So 32 million becomes 16 million. And then the 16 million, when you cut that in half, becomes 8 million. Divide that in half, you get 4 million. Okay, the 4th time will give us 2 million that remain. And then finally, the 5th time will tell me that I have 1 million atoms that remain. Okay, and looking at this problem, it appears that the first thing we're going to have to determine is the number of actual half-lives. And so we're given the number of, or the amount of time that has elapsed. We know that 19 days have occurred, and the known half-life for this sample is 3.8 days. And so if I divide 19 by 3.8, I determine that there are 5 half-lives that have passed. And so notice I have 5 grams left over, and I want to know how much, was in the original sample. Well, in order to do that, instead of having 5 times, what I'm going to have to actually do is double it 5 times. And so I'm going to take 5 and double it, so that would have been 10, and then double that, which would give me 20, double that, which would give me 40, and doubling 40 would give me 80, and then doubling 80 would give me 160. Let's see here. We doubled it 1, 2, 3, 4, 5, so we did it the correct amount of times. Should be 160 grams. We should have 2 sig figs because we have 2 here, and actually 2 in all those numbers. So 160 grams was the original sample of radon. Now this problem, if you look at it, the first kind of issue with it is that it says about 10%. So we have to kind of use what we know and get it, about as close to 10% as we can. Largely what we're going to look at is we're going to have to assume, well, we start out with 100% of the sample. And I want to know how many half-lives it takes to get to about 10. So after the first half-life, you'd be left with about 50%. After the second, you would have roughly 25%. After the third, you'd have 12.5. I'm going to go ahead and call this 3 half-lives good, largely because, if I go down one more, then I'm down to 6.25%. 12.5 is going to be about as close to 10 as I'm going to get. All right, so I look at this, I have the number of half-lives, so now all I do is put this into the formula. The number of half-lives, the elapsed time goes on the numerator. The denominator is the given half-life, which says 14.8 hours. And so in order to solve this, I am going to multiply 14.8 times 3, and my calculator will report 44.4 hours. And 3 sig figs because that one has 3. Alright, looking at this problem, let's see, I have phosphorus 32 has a half-life of 14.3 days. This time it wants to know how long it'll take to get to 1/8 of its original sample size. So I have to think of in terms of fractions. So if I start out with a whole, well, after one half-life I would have half of it left. If I divide a half in half, I get a fourth, and a half of a fourth is 1/8. And so it looks like 1, 2, 3. It underwent 3 half-lives once again. And so I'm going to set this up the same way, 3 half-lives. The elapsed time, I do not know, I'm trying to solve. It told me that the half-life for that particular radioisotope is 14.3 days. And so if I multiply 14.3 times 3 to solve for x, I get 42.9 days. And I'm going to go with 3 sig figs because of the 3 there. So 42.9 days. Alright, in this problem you'll notice that I have, let's see, the elapsed time and the known half-life. So if I take 40 days, which is the elapsed time, divide it by the known half-life of this radioisotope, that tells me that 5 half-lives have elapsed in that amount of time. I want to know how much is left from the 160 milligram sample. That tells me I started with 160 milligrams. I'm going to basically just have this 5 times. So that's going to give me 80. Divided by 2 would say there are 40. Divided by 2, 20. Divided by 2 will give me 10. Divided by 2, that should be 5. I'm going to put 5.0, so I have 2 sig figs due to the 2 there. The other numbers have 3 and 4. So I'm going to say 5.0 milligrams. And just to make certain, we did have it 1, 2, 3, 4, 5 times. Okay, in this problem, we're going to have to determine the number of half-lives again. I have the elapsed time, 11,430 years is the amount of time that passed. It looks like the half-life for this isotope, 5,715 years. And so if I divide that, I'm going to find that this is 2 half-lives. Well, let's see, and it looks like today it says the sample had 0.060 milligrams. I want to know how much was in the initial sample 11,000 years ago. So instead of dividing, once again, I'm going to double it. How many times am I going to double it? Only 2. So I'm going to start out with 0.060 times 2, which will give me 0.12 milligrams. And then I need to double that. That'll give me 0.24 milligrams. And I went with 2 sig figs due to the 2 sig figs here. Okay, on the back of this worksheet, you'll notice that some of the half-lives are given to you in that table there, so you may have to reference it. In this first problem, we have a 100-gram sample of arsenic, and we want to know how long it takes to break down to where you only have 6.25 grams remaining. So the first thing we're going to do is have to figure out how many half-lives it takes to get from 100 to 6.25. Well, I'm going to just start dividing 100 in half and see how many half-lives it takes. So after the first one, we have 50. After the second one, we have 25 that remain. Divided by 2 would be 12.5. And then divide that in half, and there we are, 6.25 grams. And so it looks like we took 1, 2, 3, 4 half-lives in order to do that. And so we know 4 half-lives elapsed. And so we want to know how much time that would take. Well, we don't know the time, but I know that the actual half-life for this radioisotope from the reference table is 33 seconds. And so how am I going to solve for the time elapsed? 4 times 33, and you end up getting 132 seconds have elapsed. 3 sig figs due to those 3. Okay, another problem where I have a fractional amount, that's not a big deal. Okay, I start with a whole, and I know, well, if I divide 1 in half, I get 1/2. If I chop that in half, I get a 1/4. If I chop the 1/4 in half, I get an 1/8. Oops, it's a little messy, but there's the 1/8. So it looks like half-lives 1, 2, 3 half-lives in order to go from a whole to an 1/8. And so I know this is 3 half-lives. And so once again, I want to know how much time it takes. Well, in looking at this, according to the table, the known half-life of gold 198 is 2.69 days. And I want to know the elapsed time, how long it takes. Once again, how to solve for x, I'm going to multiply 3 times 2.69, and your calculator is going to spit out 8.09 days. If I want to do this according to sig figs, notice there's only 2 sig figs in this number, I would round this to 8.1 days. Okay, in looking at this problem, I have to determine the percent of the sample that remains. So I'm going to begin with what I know. Okay, so I have 132 seconds, and the known half-life of arsenic 81 is still 33 seconds. And so if I divide 132 by 33, I can determine that 4 half-lives have elapsed. Okay, so basically what I'm going to have to do is I know that 100%, you start out with 100% of the material. I want to know what percentage is left after 4 half-lives. Well, after the first one, you would have 50%. After the second, you would have 25%. After the third, you would have 12.5%. And then finally, after the fourth, so after you cut it in 4 or in half 4 times, you end up with 6.25% remaining. Okay, in this problem, we start with a 500 gram sample, and it says it decays to 62.5 grams. So really we have to kind of determine how many half-lives that takes. So I'm going to start with my 500 grams. If I cut that in half, you end up with 250 grams. Well, that divided by half gives you 125 grams. If you divide that in half, you get 62.5 grams. So therefore we had 1, 2, 3 half-lives in order to reach that point. And so, once again, I know the elapsed time that is given, the 24.3 hours. And so now I don't know the actual half-life of this radioisotope, but I do know that 3 half-lives have elapsed. So if I want to solve for x, these need to switch places. So really what this is cross-multiplying and dividing. But solving for x in the denominator of a fraction, essentially what you do is you multiply both sides by x, divide both sides by 3, so these end up swapping places. So essentially this problem ends up being this. 24.3 divided by 3 will give me what x is, and when I do that, put that in my calculator, I get 8.1. And if I were going to do sig figs, this has 4, this has 3, this has 3, I have to have an answer with 3. You can always add a 0. That doesn't hurt. It just tells you with what level of accuracy your measures were taken. So 8.10 hours. Okay, finally last problem. Looks like we're going to have to start with the 80 grams and get down to the 0.3125 grams of the carbon-14. So I want to find out how many half-lives that takes. So if I start with the 80, chop that in half, that gives me 40. Divided by half gives me 20. Divided by half gives me 10. Divided in half, let's see, will give me 5. Divided in half will give me 2.5. Divided in half will give me 1.25. Divided in half will give me 0.625. Divided by half will give me 0.3125. And so if I look at the number of half-lives, I had to divide 80 in half. 1, 2, 3, 4, 5, 6, 7, 8. So we experienced 8 half-lives. All right, so now what it is asking, it wants to know approximately how old that bone is, this thing that was once living. And so once again, the time elapsed I do not know. The half-life of this isotope is 5,730 years. And so if I want to solve for x, I simply take 8 times 5,730. I get 45,840 years. I have 4 sig figs because this number has 4. This number actually has 5, so you have to go with the last 4 sig figs.